Hey guys, welcome back. So in today's video, we're going to be working with circular linked lists again, but in this time we're going to be coding up the remove Fibonacci nums method for circular linked list. So if you don't know, the Fibonacci sequence is a unique sequence that is comprised of adding up of sums of the previous two numbers. And so basically what that means is that the first two numbers are 0 and 1. And so the next number after that is the sum of the previous two numbers. So 0 plus 1, you get 1. And then when you go to the next number, 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, 5 plus 8 is 13, and so on. And so this sequence goes on forever by basically the next number is the sum of the previous two numbers. And so that's just the Fibonacci sequence. And all we want to do is, if we're given a circular linked list of various numbers, so in this case we have 2, 10, 6, 13, 8, 4, 55, what we want to do is we want to delete the numbers in the Fibonacci in the circular linked list that are in the Fibonacci sequence. So in this case, 2 is in the Fibonacci sequence, so we want to remove the 2. 10 is not in the Fibonacci sequence, as you can see over here. And so we don't want to remove the 10, and so on. The 6 we don't want to remove, and so on. The 13 we do want to remove, the 8 we do want to remove, the 4 we do not want to remove, and then the 55 we will want to remove. And so basically all we're gonna have to do is we're gonna have to go through each one. This is sort of a 3-step process, and so what we're gonna do is we're gonna go through the entire list. For the first step, we're gonna find what the largest number is, so that using that largest number we can create the whole Fibonacci sequence up until that largest number. Then we want to do, that's the second step, creating the Fibonacci array. And then the third step is just going to be looping through the entire list and removing any of the nodes whose data elements are in the Fibonacci array. And so if you guys want, pause the video and try it on your own, but if you guys have any trouble, definitely come back and we'll work through it together. So the first thing I want to do is, let me comment this, find the largest number in the sequence. And so let me just remove these comments. And so find the largest number. So I'm going to make a variable called self.head, while cur.next is not equal to self.head. Oh, I'll also want to make a variable called largest num, and we'll make that equal to cur.data. And so all we want to do is we want to loop through the entire list, and if we get to if we come across a node where the data element is greater than largest num, we'll just reinitialize what the largest num is. And so we're going to say if cur.data, actually let me remove this, while cur, say cur is equal to cur.next, and then, oh, sorry about that, I don't know. So we're over here. Sorry about that, I accidentally went to the top of the page. But we're gonna move our cur along, and first thing we're gonna do is, if cur is equal to self.head, we're just gonna break out of the loop. If I can type break right. We're just gonna break out of the loop. If not, if cur.data is greater than the largest num, we're gonna say our largest num will be equal to that cur.data. And so all this is doing is we loop through the entire list. If we get to the self.head, we're obviously going to break right there. But if not, we're checking to see if the current number that we're on is greater than the largest num. And if it is, we're just replacing it with that data element. And so in this case, if we print out our largest num, we should get 55, because that is the largest number in our list. And so first, let me remove, wrong one. Let me remove that so that it's a little easier to see. So we get 55. 55 is the greatest number in our circular linked list. So now what we want to do is with our, let me comment that, I'll say largest num is equal to 55. So now what we want to do is we want to loop through our entire, we want to loop through our, essentially until our num is less than the largest num that we found, and keep adding to our Fibonacci array. So let me code that up. I think it'll make a little more sense if I code it up. First I'm going to say make a Fibonacci array and initialize it with 0 and 1. And so what this is going to do is we're just initializing with these two, and what we want to do is we're going to keep track of what the new number that we added to our Fibonacci array, and while that number is less than the largest num, we want to keep appending to our array. And so what we'll say is we'll say num is equal to none right now, and so what we'll say is while num is less than the largest num, what we want to do, we want to say our last is the very last number in our array, in our fib array, which is how we can do that. We can get that by getting the negative first element. Our second to last is going to be the fib array -2, which is the second to last array, the second to last number in the array, and we'll say num is equal to last plus second to last. And then what we want to do, we want to append that to our array. So we'll say fib array.append num. And so each time we update with our the new num that we append to our fib array, and so once we get to a point where our number is greater than 55, we're going to stop appending. And so if I can pause that, I will print out the fib array so that we can see what it is. So we get 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55. And so we kept appending, and we got to 55 and we stopped appending right there. And so this is our Fibonacci array. And now what we want to do is we have our Fibonacci array based on the largest number, because we've already found our largest number. And so now we want to loop through our entire circular linked list, and we want to remove any numbers that are in that array. And so what we're going to say, I'm going to make a new variable, call it cur2 is equal to the self.head. Before that, I'm going to say prev is equal to none. And so now this is where we're going to remove the node. So first I'll comment this and say create fib array, delete or remove fib nodes. And so now what we're going to say, while cur2, I'm going to add pass for now. And so first I'm going to say I'm going to create another variable called old head. And so what this is going to hold is if we're in a situation like in this case, our 2 is the head of our circular linked list. And so what's going to happen is we're going to eventually, since 2 is in our Fibonacci array, we're going to want to remove our 2. And so that means we're going to have to redefine where our self.head is. And so what I'm going to say is if we want to remove our self.head, which in this case is a 2, we're just going to move our self.head along so that instead of the 2, it's going to be the 10. And at the very end, once we get to our last element, once we get through our last node and we look through everything, we if we're on the old head, that means we've gone through the entire list. And so let me go through it a little. I think it'll make a little more sense if I go through it. And so what I'm going to say now is while cur2, I'm going to say if cur2.data is in the fib array, if I can type fib array, right? So in this line, we've checked if the data element of our current node is in the fib array. If it is, we want to check to see if it is a self.head. So if cur2 is equal to the self.head, we want to reroute what our self.head is. So we'll say self.head is equal to the self.head dot next. and then we're going to say cur2 is equal to the self.head. And so that's just rerouting where our self.head is. The other case is if it is not the self.head. So this is a case where we're on the 13, then we want our 6 to point to our 8. And so what we're going to say is our prev. First, I'm going to create a variable called next, or nxt, and I'm going to save that, initialize that with the cur.next. I'm going to say prev.next is going to be equal to the next value, and then I'm going to say that cur is going to be equal to next. And so what this is going to do is, if we're on the 13 node right here, 13 is part of our Fibonacci sequence, and so what we want to say is that's why we have our prev node, so that we keep updating it. And so since our previous node is the 6, we're going to say that our 6 should point to the next, which we stored as the cur.next. So the cur.next for the 13 is the 8. And so we want to say our prev.next should then point to this next node, this 8 over here. And then we're going to say our cur is going to now be the 8 node over here. And we don't want to mess with what our prev node is, because when we go back, the prev node to the 8 will now be the 6. So we don't really have to change anything in that. And so that's just going to be if the cur2.data is in the Fibonacci array. If I'm going to say elif cur2, just for simplicity, if cur2.data is not in fib array, or actually no, we just need to say else. Sorry about that, because we're gonna have to make one check after that, and so I don't want to add that to this pattern of if and else and if and else statements. So for now, I'm just gonna say else. So basically, the only other situation is if the cur2 data is not in the Fibonacci array. So all we're gonna do in that case is we're gonna say prev is equal to cur2, and our cur2 is gonna move over to the next node. And so I just realized here, this all has to be cur2. I didn't miss any, right? cur2.data, cur2 is equal to self.head, cur2. Okay. So what this is doing is, if we get to our 10, since our 10 is not in the Fibonacci array, we just want to move our variables over. So our prev will move from whatever it is, which it might be none. It will be none in this case because we're going to remove the 2. And so our prev will then become the 10, and our new cur2 will become the 6 node. So that's why we're just moving them over. And so now, the very last thing we want to say is if cur2 is equal to our old head. So what happens now is that we get to our last node. And so in this case, we're going to remove our 55. We're going to not remove our 4. So once we get to our last node, our 55, we're going to loop through, and we're going to see that our cur2.data is in the Fibonacci array. And so since it's not the self.head, we're going to say the next value of our 55 is going to be the self.head, which is the next value of our 55 is going to be the 2. Because remember, in our original list, the last node is pointing to the new head, right? And so our 55 should point to the 2 because we never rerouted what our last node points to up here. And so since our 55 points to the 2, that means our cur2 at that point will be equal to the old head, which is over here, because our old head is the 2. Before we started anything, we initialized our old head variable to be the node that held the data value 2, which was a self.head. And so what we're going to say is that our prev.next should point to our new self.head. And so the reason we're doing this is, in this case, we removed our 2. And so we reinitialized where our self.head was. So we said our self.head is going to be the self.head done next because we're just moving it over. And so what we're saying over here is that once we get to the 55 and we've handled for it and everything, and after the 55 is the 2 node, because we never repointed where the 55 points to. Since now we're at our old head, what we want to say is that our prev next, which is a 4, it should point to our new head node, which it will be the 10. And so by doing that, we are kind of cleaning up our array and make sure it all points, the last node points in the right direction. And so if we didn't have this, it wouldn't really matter, because our 4 would, if we didn't have this and our 55 was pointing to the 10, then it wouldn't really matter, because our 4 would automatically point to the 10. But this is good for handling a situation like this, where we removed in a situation where we moved our self.head over. And so we keep doing that, and so we basically, our last node is then pointing to our new self.head, and then we can just break out of that loop. And so that is removing our Fibonacci sequence. If I print this all out, I get 10, 6, and 4. And so if we look at our list, we wanted to remove the 2 because it's in our Fibonacci sequence. Actually, let me print our fib array again, just so that we have it here to compare. Fib array. So this is our Fibonacci array right here. And so if we look at it, we want to remove the 2 because our 2 is in this Fibonacci sequence here. Our 10 is not in the Fibonacci sequence, so we didn't want to remove it. Our 6 is also not in the Fibonacci sequence, so we didn't remove it. Our 13 is right here, so we want to remove our 13. Our 8 is right over here, and so we want to remove that. And our 4 is not in the Fibonacci sequence, so we didn't want to remove that. And of course, our 55 is at the very end here, so we want to remove that. And so once we removed everything, we want to get be left with a 10, or a 10, a 6, and a 4. And so this example is kind of good because it handles for some of the different head cases, because we handled for removing our self.head, which we did over here. If our cur.data was equal to self.head, we just reinitialized where our self.head was, so we just moved it over. These 3 lines handled for removing the 13 node, the 8 node, and then when we got to the very end, we ran these lines of codes. And so at this point, when we got to our last node, which I'll comment over here, when we got to our last node, our prev was the 4 element, and then our next, or / cur, because cur2, because we said our cur2 will be equal to the next, was then pointing to the 2 node, because up here when we shifted our self.head over, we never went through to the very last node and rerouted where our self.head was pointing to, or our last node was pointing to. So this was still pointing to the 2 node, because that's just the array of, that's just the sequence of the circular linked list. So once we got to the very last node, our next was the pointing to the 2 node up here. Since this was, we saved it, that's why we saved it as the old head over here, because now that our cur2 is equal to the old head, all we're saying that is that our prev, which is a 4, now points to our new self.head, which is, this is our new self.head. And so now our 4 is pointing to the 10, and we just break out of our while loop right there. And so that is removing the Fibonacci nodes, or Fibonacci numbers, out of our circular linked list. I know this is a long video, but hopefully it helps you guys. Until then, thanks for watching, and see you guys next time. All right, later.